Alright guys, so if we are looking at simplifying, the first way we're going to simplify is to FOIL. So we're getting rid of our parentheses by following order of operations. So you're going to do first, outer, inner, last. So we're going to FOIL those first couple terms. So you have x squared minus 6x plus 9, 4x squared minus 4x plus 1, and x squared plus 8x plus 16. Does anybody remember what 1, 2, and 3 are called? Perfect square trinomials, yes. So when you FOIL them, they are perfect square trinomials. If I asked you to find the roots, what are all of the roots? How many solutions do each of these equations have? One. Which makes them what type of root? Starts with an R.
Real. Ratified.
It was. But you got the word. It's a repeated root. A repeated root is when you factor it and you have the exact same binomial factors. So you get your answers. You get x equals 3 twice. You get x equals a half twice. That's a repeated root. There's only one solution, which means my vertex is on the x-axis. It also means if you did those problems as the quadratic formula, your square root or discriminant value would be 0. So I'll give you that was your thought. All right, and then 4, 5, 6, 7, that's like what we did at the beginning of 5, 4. Simply simplifying square roots. If you have a negative under your radical, it becomes an I. If you have a fraction, you treat it like the top and the bottom separate, and that plus or the minus stays in front. So the reason I bring all of those up today is because we're going backwards kind of. I do 5, 6, then 5, 5 in our book, but we are looking at completing the square. When we complete the square, we are taking into account the idea of finding a value that will make a perfect square trinomial. So we are going to be creating perfect square trinomials. That's what our goal is today. So we do that by following the process and the steps I gave you below. By creating a perfect square, we create a quadratic that we can solve. So again, our objective is to solve equations by completing the square, and our big topic for this chapter is writing or solving quadratic equations. So the step to solve by completing the square. First, you need to get this equation in a form we usually don't put it in. We're putting it in a form where it is equal to C. We're putting it in a form where it is equal to C. So that's unique to what we've been doing. Then, the other stipulation is that my A value must be 1. So if A was 2, we would have to divide everything by 2 to make A 1. Now we're going to look at examples. Part 2 is you're going to take the B term from BX, divide it by 2, and square it. Now you're going to add that number to both sides. We add it to both sides because by adding it to the right side of the equal and adding it to the left side of the equal, we keep our scale balanced. And then you're going to factor the left side because by adding it to the left side, you have created a perfect square trinomial. So it is always going to factor like our warm-up problems. It's always going to factor like our warm-up problems on the left side. And then we're going to use that square root technique to solve for x. So again, another technique that allows us to solve for x that isn't factoring. So the past few sections, everything we've been doing is finding the roots of the quadratic, and there are pretty much these three main techniques. So let's walk through it. You have x squared plus 4x plus n. What number would I need to add to that to make that a perfect square trinomial? Oh yeah, sorry. Because it's b divided by 2. I thought my next one is 4. And I looked at the wrong example. So yes, it's b divided by 2, which is 4 divided by 2. 2 squared is 4. So the number we're going to add is 4. Sorry. Does that make sense? So by adding that 4, you've created a perfect square trinomial, which means it will factor as x plus 2, x plus 2, which is x plus 2 squared. All right, so completing the squares is a manipulation of perfect square trinomials. Completing the squares is a manipulation of perfect square trinomials. So what I want to do is complete the square for 1, 2, 3, and 4. So we're going to do that by taking the middle term, squaring it, and then adding it. So in number 1, my middle term is 10. So we take 10 divided by 2, square it. So 10 divided by 2 is 5. 5 squared is 25. So we have completed the square by adding 25. A negative does not affect completing the square, because no matter what, a negative times a negative is always a. So when you square that b value, it's always going to be positive. So you could bring it in for negative b divided by 2a, but you should have the understanding that it's always going to be a positive that we add. That's why I put all the plus signs there. We're always adding up something. The signs for the completing the square always come from the middle term. So 6 divided by 2 is 3. 3 squared is 9. Number 3, 5 divided by 2 squared. So again, the square goes to each term. It's okay to add a fraction as you're completing the square. So you can add to that 25 halves. And then number 4, we have x squared plus 1. So 1 divided by 2 squared gives 1/4. So you complete the square by adding a 4. Yes?
Would it be 25 over 4?
Oh, thank you. That's as hard as today is really going to get. We're going to look at the next 3, which the difference from 1, 2, 3, and 4 is an equal sign. So again, you have to go back to the first steps in the directions. You want ax squared plus bx plus something equal to c. So we don't want this c value with us right now. We want this c value on the other side. So you have x squared plus 6x equals 2. So you're going to complete the square. So you take b, which is 6, divided by 2. Square it. And then here's where it's different from what we were doing before. You add 9 to the left and we add 9 to the right because you have to balance your scale. Add 9 to the left, add 9 to the right. Ooh. I was a little angry. Okay, so now that makes the left side a perfect square trinomial. So that factors as x plus 3x plus 3 or x plus 3 squared, combining 2 plus 9 to give 11. So then what we want to do is solve for x. So we're going to square root both sides. Okay. So you get x plus 3 equals, and this is where you have to be careful, plus or minus 11. Because when you take a square root of a number, it's the positive or the negative. When you have a square root, you just follow what it is. So that gives x equals negative 3 plus or minus root 11. And if you had done this in quadratic formula, you would have gotten that same answer. You can almost see how this answer kind of looks like a quadratic formula answer. What's nice about this form is what if I told you y equals x plus 3 squared minus 11? What form is that? Not standard. We live in standard form. It's the other form. What's that other form called? Oh, that's lines. The one that gives you the point here. What's this point here called on the question? Yeah, so this is vertex form. So you can actually complete the square to find the vertex. You can complete the square to find the vertex also now. So like we're going backwards to graphing it a little bit. So some people like completing the square to help them get to vertex form. It's just something to keep in mind. Okay. In number 2, remember I told you you can have an a value equal to a number. We can't complete the square without dividing everything by 4. So divide everything by 4. So you get x squared plus 2x equals 3/4. Now complete the square and add that value to both sides. So 2 divided by 2 is 1. 1 squared is 1. So we're going to add 1 to the left and to the right. So you get x squared plus 2x plus 1 equals 3/4 plus 1. That factors as x plus 1 squared equal to 7/4. And then you solve by square rooting both sides. What makes this one nice is that 4 is a perfect square. So you can get rid of the radical in the denominator and you get x equals negative 1 plus or minus the square root of 7 all over 2. Square root of 4 is 2. Hence the warm up again, looking at how you can break fractions of radicals. Yes.
Do you have to do this simplifying the 4 part?
Yes. Yes.
What if it's
For
like,
rationalizing the denominator, you can't leave a square root in the denominator.
what if it was like 4/7? You have to simplify the 2 at the top.
Yeah, you should.
So then it would just be 2 over 2 over 7.
Correct. Yes.
Can you just leave it as parentheses?
Yeah. Yeah. You're solving for x. Okay, and last we have x squared minus 10x minus 8 equals 16. So just like in the past, we had to get it set equal to 0. Now we need to get it set equal to C. So C is all the linear or constant stuff added together. So we're going to add 8 to both sides. So we get x squared minus 10x equals 24. Now we're going to complete the square on the left. So you have 10 divided by 2, which is 5. 5 squared is 25. So we're going to add 25 to both sides. And nicely enough, 24 plus 25 is a perfect square. So you get x minus 5 squared equals 49. So we get x minus 5 equals plus or minus the square root. Interesting. Plus or minus the square root of 49. So you get x minus 5 equals plus or minus 7. So then you have to do x equals 5 plus 7 and x equals 5 minus 7 to get x equals 12 and x equals negative 2.
Homework tonight, because